Video is about side and angle relationships in triangles. Two objectives we're going to try to get done today. Objective one, we're going to try to determine if three given side lengths can form a triangle. We're going to try to do that two ways. One way is they're going to give us three side lengths, and we're going to determine can those be put together in some way to form a triangle. And then we're going to find is there a way to find out what the range would be between those three. But that'll be objective one. We'll talk about that first. Objective two, we're going to try to determine how side lengths and angle measurements are related. And if we can do those two things after this video, then we would have accomplished our goal. All right, so the first thing is how are side lengths and triangles related? All right, so first thing is let's talk about, we have this example. These are our list of 5 side lengths. Okay, they're all in perfect proportion. So you have side length 10, 7, 3, 6, 4, and 2. Those are all side lengths. So the question is, which of these can we put together and piece together that would make a triangle? So let's take this 10 up here, and let's see what would happen if we use side length 7. All right, so there's potentially what one of them may look like. So do these work? Do 2, 3, 4, and 6, can they meet at the end of this 7 and somehow meet at 10? We'll take the 6 first. So can we have a 7, 6, 10 triangle? All right, let's take a look. Let's try to angle this correctly. Yeah, I think you could. You could manipulate this to where, I could make a triangle out of that. Okay, so you can kind of see that may potentially work for a triangle. So 6, 7, 10, that would make a triangle. All right, so let's try 4. Let's try side length 4 with that 10 and 7. Can I make a triangle with side lengths 7, 4, and 10? Let's see if we can rotate this and see. And I think you see, yep, there's a way I can do that. I can make that work. I can make that a triangle. Okay, so 7, 4, and 10 would work. All right, what about 3? Let's take a look at 3 and see if that would work. All right, I'd have to kind of bend this around, see if that would work. So the question is, would these ever touch and make a triangle? And the answer is no, they wouldn't. Okay, but the question is why? Why would they not form a triangle? Well, if I take 7 and 3 and I put them back to back right next to each other, that's going to form segment 10. Well, that's what that side is. So there's no way to make a triangle out of 3, 7, and 10 if I combine 3 and 7, and I would just get 10. So that's not going to happen. So we said yes on 4. We said yes on 6. So what about 2? Well, if 3 didn't work, then 2 is not going to work for sure. There's no way to connect those and get a triangle. So 2 is not going to work. Okay, let's try another combination. Let's go 6. We already tried 7 and 10. Let's go 6, 4. And let's try 2. Can 6, 4, and 2 work? Well, it can't because of the same reason that 7, 3, and 10 won't work. Because if I combine 4 and 2, that gives me 6, and I can't get a triangle out of that. Well, would 4, 3, and 6 work? Yeah, I think you can see where I could manipulate this, and I could get a triangle out of that. All right, so what this activity is trying to get you to understand is, all right, in order to make a triangle, 2 of the smaller side lengths has to be bigger than the third. If it's not, just like 7, 3, and 10, that cannot make a triangle. And just like 4, 2, and 6 can't make a triangle because you can't make angles out of that. All right, so what we're trying to understand is if I add the two smallest, it's got to be bigger than the third. So that's the conclusion. The sum of any two sides must be greater than the third. And the idea goes back to when you talked about right triangles and hypotenuse, right, Pythagorean theorem and all that. This is Pythagorean theorem only works for right triangles, 90 degrees. All right, this side opposite that, if you remember, it said it's got to be 90 degrees, and it's called the hypotenuse, and hypotenuse has to be the longest side. Okay, so to be the longest side, it's the longest side because it's opposite the largest angle. You can't have two 90-degree angles in the same triangle. Right? If you remember, triangle has to add up to 360. The angles inside, the interior angles have to add up to 360. So if that's true, you can't have two 90s, and that's why your hypotenuse has to be the longest side. Has to be the longest side. Okay, so go back to the example we just did. If we have side lengths 5, 8, and 12, 5, 8, and 12, can those somehow be put together to make a triangle? Well, all I'm going to do is I'm going to add the two smallest, and it has to be bigger than the third. All right, so the two smallest are 5 and 8. 5 plus 8 is 13. 13 is bigger than 12. So yes, that would form a triangle. All right, and I got 12, 24, and 36. So take the two smallest, 12 and 24. 12 plus 24, 36. 36 is not bigger than 36. Remember, it's got to be greater than. All right, so that would be a no. It's got to be greater than the third. All right, then I have number 3. I have 15, 20, and 36. 15 and 20 are the smallest. 15 and 20 is 35. That is smaller than 36, so that third side would be greater than, so that would be a no. That would have to be 35 plus 20 would have to be bigger than the third. All right, number 4, I have 18, 28, and 11. Now be careful with this. Make sure we're taking the two smallest. So the two smallest are 18 and 11. 18 plus 11 is 29, and 29 is bigger than 28. So that would be a yes. All right, and then number 5, I have 29, 12, and 20. 12 and 20 are your two smaller sides. Add those two, I get 32, and 32 is bigger than 29. So that would be a yes. Okay, so a second way they're going to ask this is, okay, using this idea, what are the possible third length sides of this? So if I have 5 and 8, we know 12 works, right? It's this same question. 5, 8, 12 was a yes. But what can be the minimum number and what can be the maximum number? So that's going to give me the range. So the possible lengths of the third side of the triangle, the range. All right, so going with this idea, the sum of any two sides must be greater than the third. So 5 plus 8, that third side has to be bigger. Sorry, 5 plus 8 has to be bigger than the third side. So 5 plus 8 has to be bigger than the third side. So that third side we're going to call x. Okay, that means all three of these situations. So whatever 5 plus whatever x is, right, the sum of any two sides has to be bigger than the third. So that has to be true. So the three statements that have to be true is 5 plus 8 has to be bigger than the third side. 5 plus that third side has to be bigger than 8. The sum of any two sides must be bigger than the third. All right, and then 8 plus that third side, right, has to be bigger than 5. So these are your three statements right here. All right, so all we have to do is solve those inequalities. Okay, so it's just like an equation. So to solve this, 5 plus 8, 13. So to solve that, it would have to be x. All right, 13 is greater than x. So 13 has to be greater than x. All right, if I solve this, all right, to get x by itself, you subtract 8. 5 minus 8, that's a negative 3. So x has got to be greater than negative 3. And then in this little simple one, we would subtract 5, so x would have to be greater than 3. So here's what we would get when we solve those inequalities. Well, what we're doing is we're finding the lengths of a side. Well, lengths of a side have to be positive. So this statement right here, this middle statement, when I added x plus that third, or 8, plus that third side greater than 5, says x is greater than negative 3. Well, a side length can't be negative. So if this statement is true, right, negative 2 is greater than negative 3, but you can't have a side length of negative 2. So we're pretty much throwing out this statement, okay, because you can't have a negative side length. So we basically just take these two statements right here, right? 13 has to be greater than x, or x less than 13, however your statement wants to be, and x has to be greater than 3. All right, and that's your inequality. That is your range. So you can write this one of two ways. You can do 13 is greater than x, and then x is greater than 3. All right, this statement. Or you could flip that in the less than symbols. Okay, either way, these two things say the same thing. Right? This one says x is less than 13. This statement also says x is less than 13. All right, the right side of this statement says x is greater than 3, and this statement says x is greater than 3 also, just written differently, okay, with the greater sign up here, less than sign down here. Now, simple way to do this, especially if you have ABCD tests, a multiple choice test, is pick a number in that range, a number that is greater than 3 but also less than 13. Let's say 10. We'll put 10 in there. Does that work? We'll take the two smallest, add them together. Is that bigger than the third? And that would be true. So this would be your answer to this potential question. They could write it different ways, but this is the statement that you're looking for. Okay, so we're going to do that to each one. First, you write the statements, the three statements that have to be true, figure out which ones are relevant, and then you kind of come up with your answer. So right here, 12, 24, what is the potential third side that would work? Well, go the same idea with this one. So 12 plus 24 has to be bigger than the third. 24 plus the third, whatever it is, has to be bigger than 12. All right, and then the third plus 12 has to be bigger than 24. So here's your three statements. Now, again, what you get when you solve that, right, 12 plus 24, 36. If I subtract 24, I get that negative. X is greater than negative 12. And I subtract this 12, and 4 minus 12 gives me 12. But again, just like this statement up here, we're going to kind of disregard this x is greater than negative 12 because that's assuming that negative 11 is an answer, and it's not. Side lengths cannot be a negative. So we're taking these top two, combining them, and there's my answer. So x has got to be somewhere between 12 and 36. Okay, now greater than 12, that means it can't be 12 because if I put in 12, that's just like this question right here, the second question, where 12 plus 12 is 24, and that's wrong. It's got to be bigger than 24. Okay, so shortcut, we're going to eliminate this step to where we get a negative. I mean, don't even write it down. So here are your statements for number 3. But you see where this 20 plus x greater than 15, I'm going to get a negative 5. So once I see that, I'm not even going to write that. So I solve the rest of it. Right, you add to get this one. You subtract 15 to get this one. And there's my combined statement. So that's your shortcut. All right, to get the potential range, to get the range of potential values, I'm going to add the two. Right, just like I did here. I added the 2 to get the biggest number. I subtracted the 2 because, again, you subtract 5 here to get the smallest. And then I combine my answers. Okay? Now, again, if you subtract 5 minus 8, understand that's a negative and that's not going to work. That's this one right here. Okay, we're ignoring that one. All right, so shortcut, add them like we did this. add them, that's the 35. Subtract them, that's where I get the 5. All right, so that's how you find the potential third values or third side lengths of triangles. All right, let's talk about how angles work. So go back to the idea that, right, hypotenuse, right, this has to be the longest side. In this example, this side length would be 13.96, and that is the longest because that is opposite the 90 degrees. Well, that's pretty easy to find, but what about these other two angles? We have to put those in order of either greatest to largest or greatest to smallest or smallest to largest. All right, so right now, I do see this. I got my side lengths of 5.4, right, we'll round it, and the other side lengths is 12.88. All right, so based on that, let's go greatest to least angle. So my greatest is 90. I know that. But what is M? M in this case would be 67.3, and N in this case would be 22.8. Okay. So go back to the same idea of hypotenuse had to be the longest side because it is opposite the largest angle. It's the same idea with the other one. So the next largest angle, right, would be 67.3. Well, the side opposite that has to be the next longest side, and it is. So the smallest angle has to be opposite the shortest side, and it is. So in the examples we're about to do, we'll be given angles and have to find sides, and we'll be given sides and we have to find angles. So this example right here, we'll just use what's given here. All right, so let's go, first thing, let's go greatest to least. Greatest to least. So to find the greatest, all right, we're talking about sides here. To find the longest side, we need the largest angle. So the largest angle here is 82. Opposite that would be FL, side FL. Right, that angle produces the opposite side, FL. So FL, or LF in this case, is going to be the longest side. Now, if you recognize the greatest to least, we're using these greater than symbols and just filling in these gaps. Okay? Let's actually make this different. So 83, we changed that to 83, but it still makes FL the longest. So the next largest angle is 51. Opposite that is ML. So that would be my next longest. And then my smallest angle is going to produce my shortest side, which is FM. Okay, that's how we would do that. Now, what if it asks it in reverse? It asks me least to greatest. And you see if it asks least to greatest, my inequality statement is going to have my less than symbols. Okay, so if it asks least to greatest, I'm starting with the smallest angle, which is 46, and I'm starting with FM. So basically, these are going to switch, and ML is going to stay the same if it asks for least to greatest. So greatest to least, I'm finding the largest angle first. Least to greatest, I'm finding the smallest angle first, and then I go from there. Okay, so what I want you to know is the longest side is opposite the largest angle, and also the shortest side is opposite the smallest angle. So whether we're going greatest to least or least to greatest, we need to understand that idea. But also the converse of that, which if you go back to conditional statements, we talked about converse. If we flip that, now understand this converse. If two sides of a triangle are not congruent, right? So here's the idea. If two sides are not congruent, again, the sides and the angles are related. So if the two sides are the same, that means two angles have to be the same. So if we have this, where both angles are 49, not two of the three angles are 49, that means this side, right, opposite this 49, is going to be the same as the other side opposite that 49. Well, I don't then these two sides have to be the same. So this statement is a little different. But this converse is saying that is not true if two sides of a triangle are not congruent. Okay, which also, all right, if we have two sides the same, that's called isosceles. If we had three sides the same, that's equilateral, right? And all these would be 60. Okay, so this statement would not be true. But if the two angles are not congruent, if two sides of a triangle are not congruent, then the largest angle is opposite the longest side. And that would also be true just going in reverse. All right, let's do some examples. I say we're given the side lengths. And this one asks us, read directions carefully, order the angles in each smallest to largest. So we're given sides, but we're talking about angles. So smallest to largest. So smallest angle, I'm looking for shortest side. So 6 in this example is the shortest side. That is opposite angle C. So again, going shortest or smallest to largest, we have the less than symbols. The next shortest would be 6.54. That is opposite angle A. And the next one, actually the largest, is going to be 7.97. That is opposite B. So this would be your inequality statement of smallest to largest for this triangle. All right, we'll do another one. E, same thing, smallest to largest. So shortest side is 4.78. That is opposite angle E. So E is your smallest. Next smallest is 7.79. That is opposite angle F. And your greatest or largest angle is opposite this longest side, which would be D. And there's your inequality statement for that question. Okay, another type of question, but it's the same idea. If they say, all right, I'm going to give you a triangle GHI. Right, it doesn't give us a triangle. It says, I have a triangle GHI, and these are the three measurements of those sides. Put them in order. Again, same directions. Put them in order, smallest to largest angle. I know smallest to longest side, or shortest to longest side. Here's my advice on this one. If you don't have a diagram, draw one. I will show you a shortcut, but if you don't have a diagram, draw one. It doesn't have to be accurate, right? GI doesn't have to be 25, and it just draw you a diagram so you can see something, see a triangle, visualize it. All right, and then plug in, substitute what you know. I know it gives me HI is 15. So in my triangle, I'm going to put 15 at HI. It tells me GI is 25. It tells me GH is 13. Again, don't worry about if your triangle is accurate or not. I just need a visual. So again, directions, smallest to largest. So I'm looking for shortest side. So the shortest side is 13. Opposite that is angle I. So angle I would be the smallest angle. Next one is 15. That represents HI. That's opposite angle G. And that would make H my largest angle, which is opposite my longest side. And that is true. Okay, now shortcut. Again, this is shortcut only if you choose to use it. If you don't, that's okay. I think it's a good idea to draw a circle. But you're going to see a pattern that, okay, if I'm talking about HI in a triangle GHI, side HI goes with angle G. Side GI goes with angle H, right? The other letter in the statement, GHI. And GH is going to go with I. So if you can understand that, you don't have to have a diagram. You can just go with that. Right? So you put your links in order and match up your angles with that, and you can do it that way. All right. Now, what if it asks for let's order them from largest to smallest. Same idea. But if I'm going largest to smallest, I want to start with my longest side. So my longest side is here, which means my largest angle is B. So you recognize when it asks for largest to smallest, now we're using this greater than symbol. All right, next, longest is 6.54. That's opposite A. And the smallest, shortest side is this. That means smallest angle is C. That's your inequality statement for that one. All right, same as before. It gives me a statement of triangle GHI. If you want to draw one, draw one. I think it's a good idea. All right, so again, doesn't have to be accurate. So HI is 28, GI is 12, and GH is 18. So that's what the triangle would look like. And then based on that, I go. Again, follow directions, largest to smallest. So I'm going longest to shortest. Longest side is this. That means G, right? G is opposite HI. G would be your largest. 18, next longest. That means I would be your next largest. And that leaves H as your smallest. Okay, so there's how sides and angles are related in that way. All right, example 3. Now it's giving you angles, and you got to go in reverse and talk about sides. So, angles. This says shortest to longest. I'm going to do the order from shortest to longest, so I need to go smallest angle first. Smallest angle right here is 47.6. Opposite that is BC. So BC is going to be my shortest side because it is opposite the smallest angle. All right, next one, this is the next smallest angle. So opposite that would be CA or AC, whichever they write it. And then AB would be the last one, which would mean it would be opposite the largest angle, and it is. Okay, so if it just asks for a list, this would be the list. Now, if it asks for inequalities, right, shortest to longest, you would have your less than symbols, shortest to longest. All right, number 2. Again, it gives you the statement. You have triangle DEF, and here are the measurements of those angles. Angle D, angle E, and angle F. I would write or draw, sketch a diagram. So I sketch me a diagram. I'm going to plug in 50 for D, substitute 48 for E, and substitute 82 for F. And then treat it just like number 1. Directions say shortest to longest. I'm going to go smallest angle to biggest angle. Smallest angle is 48. Opposite that is DF or FD. In this case, they put FD. Then D, angle D is the next smallest. That's opposite EF. And that would mean DE is your longest side. Okay, so that is those listed in order from shortest to longest. Okay, then it's going to ask you a little different way. They're going to only give you 2 of these angles, and you have to find the third. That goes back to the sum of the interior angles of a triangle have to be 180. So if I know that, and that's 100 and that's 50, now that's 150, 180 minus that, then angle A has to be 30. So I'm going to have to find that angle. And then I treat it like the previous ones. Now this one says longest to shortest, so I'm going to go largest angle to smallest angle. Largest angle is 100. That means AC or CA would be the longest. Okay, next largest angle is C. That means AB will be the next longest. And BC, because we're going longest to shortest, BC better be opposite the shortest angle or the smallest angle, and it is. So that would be the order of that one. Okay, this one right here. Again, just like the diagram only gave you 2, I had to find a third. Got to do the same thing here. It gives me a it says I got triangle DEF. Now, order is important. Order is important. You have to make sure you put it in the correct order. It says angle D is 25, angle E is 136. Write it longest to shortest. That means I have to find that third one. So I add those 2. All right, 136 and 25. That's 161. Okay, then I go 180 minus that. 180 minus 161, I should get 19. All right, and that gives me angle F. I knew angle D, and I knew angle E. All right, so again, I go longest to shortest. So largest angle, 136. Opposite that is DF, in this case FD. 25, the next one. So EF would be the next, and then DE would be your last one. Okay, so there's all the situations they're going to ask for with the idea of the largest angle is opposite the longest side. Okay, so here's the two ideas. If we're going to accomplish our objectives, we need to understand these two ideas. So the longest side is opposite the largest angle, but also the shortest side is opposite the smallest angle. Okay, and this statement would be an answer to a question that asks you to go least to greatest or shortest to longest, because of your less than symbol. And then the idea that the sum of any two sides, sum is add. I'm going to add any two sides, and it's got to be bigger than the third. Okay, and then we talked about how to find the range of that. So those are our objectives, and if we can understand those, then we have accomplished our goal today, and then we'll do some work on those later on.